Hi everyone, in this video I will talk about normal random variable and standardization with z-score. So we have normal random variable and the distribution of a normal variable distribution is a normal curve shape, which is the bell shape, like this. For a normal distribution, or to describe a normal distribution, we have two parameters, right? So we have the mu, which is the mean, and we have the sigma, which is the standard deviation, standard deviation. The mean tells you where is the middle, right? And then the standard deviation tells you how spread out are the data, right? So it's the shape of the normal distribution. Okay? So when you have two parameters, mean and the standard deviation, you will be able to describe a normal distribution. So now the question is, can we compare two normal distributions? So the question we're going to ask is, can we compare two normal distribution? Okay, so before we answer this question, let me give you an example. Say Michelle, when she applied to college, she took the SAT and got a score, say 600. And then for Steven, when he applied to college, he took the ACT and got a score of 25. Okay, so let's talk about the national values. So for the national average, right? So if we see the national as a population, so the SAT national mean is 514 and the standard deviation is 118. And then for the ACT, the mean is 20.7 and the standard deviation is 5. Okay, so who's better? So who has a higher percentile? So the question is, who's better in terms who's better in national percentile? Okay, so who's better, or in other words, who should the school admit, right? If they only look at their test scores, right? Who's better? Now it's very hard to compare, right? It's very hard to compare because they are basically two normal distributions. They're very different. You know, they have different mean and different standard deviation. Only looking at their score, it's just really hard to compare them, right? Really hard to compare them. Okay, so it's hard to compare. Okay, hard to compare. So we need a way for us to be able to compare these two. People, or in general, can help us to compare between different normal distributions. So we need standardization, right? So we need to standardize all the normal distributions for us to compare them. When we do the standardization, we are getting what we call the z-scores. Okay, z-scores. And then when we get the z-scores, when we do the standardization, we'll be able to get what we call a standard normal. Standard normal. And what's special about standard normal is that for standard normal, its mean is always equals to 0, and then the standard deviation is always equals to 1, right? So 0 mean, 1 standard deviation. And let's see how we're able to get the z-score. Okay, let's look at it from the formula. So z equals to x minus mu divided by sigma, right? So if you have the round number or the original values subtracted its mean, you are gonna get mean to be 0, right? So you're gonna shift the middle to be 0, and then divided by its standard deviation, it's gonna give you standard deviation equals to 1. So z here will have mu equals to 0, and then standard deviation equals to 1. Okay, so remember, or not remember, but let me just write this. The mu here is for the z, the standard normal, and then the sigma here is for z, is the standard normal's sigma, where these two are from the original values or original data. Okay, good. So what is the interpretation for z? Z here, the interpretation is how many standard deviation away from the mean. Okay, so z-score here tells you the value you're looking at, how many standard deviation is this value away from its mean. Okay, so that's the interpretation for z. Now let's go back to our example and standardize Michelle and Steven's score. Okay, let me back to the example that z Michelle, so we're going to apply that formula, is equals to a score 600 minus the national mean 514, and divided by the standard deviation 118, and this equals to 0.7288. Okay, so how to interpret this value here? This value tells us that Michelle's score is 0.7288 standard deviation above the national mean, right? So Michelle's score is above the mean, it's above the national mean, it's above average mean, and how much is above the national mean is 0.7288 standard deviation above the national mean. Okay, let's look at z Steven. Okay, z Steven equals to 25 minus 20.7 divided by 5, that's equals to 0.86. So Steven's score is 0.86 standard deviation above the national mean. Okay, so Steven's ACT score is 0.86 above the national mean. And now we're ready to compare, right? Since the two scores are now being standardized and their units are how many standard deviation above the mean. So now we can compare. So we can compare, and the conclusion we got from here is Stephen did better than Michelle, right? It's only because Stephen is 0.86 standard deviation above the mean, and Michelle is only 0.7288 standard deviation above the mean. Okay, this video shows us how to get the z-score by standardizing, and we can use the z-score to compare between normal distributions. In the next video, I will talk about how you can get the percentile from the z-score. Thank you for watching. I will see you in the next video.